should be qualified, I think. So I'm Lisa Little. I am faculty here at USC. I've been teaching here about 10-ish years, maybe longer, and taught at Woodbury before that. I also am a licensed architect in the state of California. I did my undergraduate degree at Georgia Tech in electrical engineering a long time ago, and then I did a master's degree at SciArc here in Los Angeles. And today I'm going to show two recently completed permanent public art projects, one at the University of Washington in Seattle and the other at Oregon Tech in Scappoose, Oregon, just outside of Portland. Both of the projects are very large suspended canopies located in interior spaces. So Vertebrae Art and Architecture is a multidisciplinary studio that I founded in 2013. Regarding the multidisciplinariness of it, we are working in both the field of art and in architecture. On the art side, we do large-scale public art projects and installations like the ones you will see here today. And then on the architecture side, we do ground-up construction residential projects, residential remodels, commercial projects. Over the last few years, we've won several AIA awards for our projects in both the residential and commercial categories. But again, today I'm going to be speaking about our art projects. So in my research and practice, I am very interested in questioning the role of technology in terms of both design and fabrication and making. So often I think that I must look like someone who's wholeheartedly embracing technology, and that may be true given my background as an engineer and my fascination with how quickly new ways of designing and making are coming online. But there is also a criticality involved. I have a streak of alarm, or maybe just concern about what we might be losing as technical capabilities become more and more pervasive. But I also 100% believe it is not possible to stop or even slow down technical advancements. It is futile to resist. So I channeled my concern into focusing on how do we actually use technology to hold on to the things that otherwise might be getting lost. Questions around craft and the hand, the natural, the organic. In preparing this lecture, I decided to look back at some previous work and research, including art installations and some topic studios I've taught here at USC, to examine the arc or path that has led to the work I'll show today. I think, at least for me, it's not always such an intentional path, but instead it evolves or emerges somehow as technology emerges, as my formal and material interests change over time. But there's always a deep motivation to push the technology to see what it can do. So these four images are from four different folded metal installations done earlier than the work I'm showing today. The one on the far right was installed here at USC many years ago. In that work and in my current work, I'm interested in questions around formal relationships that are inherently structural. In all of these projects, the system is both the form and the only structure. The two images on the left were done together with Emily White under the name Layer, which we formed a few years after graduating from SciArc, and the two images on the right were done with Vertebrae. In all of these examples, the building unit is planar. It's made from planar metal, powder-coated folded metal, either steel or aluminum, and that usually depends on the budget. The aluminum is more expensive, the steel is cheaper. And all the work I'll show today comes after this planar work, and all the work I'll show today is made from line and node-based systems. So in the spring of 2017, I co-taught my first topic studio here at USC entitled Robocraft with Scott Mitchell, who I think is here somewhere. USC had just gotten our KUKA robots, and I was interested in using them to push on ideas about how to use technology to simulate the craft or hand. So because I was perceiving that we were losing all these things in design and fabrication methodologies as our field advances, both in the computational design aspect and in construction. So for the midterm, students made drawings using ink and our smaller KUKA robot. Their drawings were, not surprisingly, given a robot moves from point to point in space, line-based drawings, and there was a quality to them, I felt, a beauty, that came, frankly, from two analog things. One being the physical media, the various pens and inks and papers that the students selected for themselves and tested, and the other resulting from the fact that the robot was on a cart and the students had to roll it out of the space and back into the space, and they hadn't really mastered the ability to calibrate that robot. So the plane of the drawing surface was not parallel or perpendicular to where the robot thought it was by just a little bit. So that first factor, media, brought the quality of hand or craft that was very intentional and curated by each student through their selection of media. And the second was, I felt, a fortunate side effect of working with new technology. So those two things combined brought about this hand or craft quality that we were after in the studio. And here are some of the resulting final robot images. These were all shown various digital design and fabrication processes to find out ways to augment, enhance, or otherwise improve this situation by introducing or purposely mimicking distinctly human elements, but using digital processes to do so. So again, I'll just show a couple students' work. These are mid-review drawings on the left and final drawings on the right from that topic studio. So like sort of line-based drawings and then a building inspired by that. In this studio, all the students started by making objects by hand and then doing photogrammetry scans of their objects to digitally capture the qualities that we were interested in. This example is from former student Ryan Cripps. On the right is a handmade object he made from twine and glue, and a kind of little frame that he built. And he did an entire series of these beautiful handmade objects in the mid-review. And then on the left is an elevation of the design that was inspired and informed by the handmade objects, but using computational methods for the final project. So following these studios, I did a temporary art installation commissioned by the Los Angeles Department of Public Health as part of a pop-up art show. The mission of the show was to raise awareness around mental health, and particularly teen mental health. The topic of intersectionality was assigned as part of the commission for the art. Intersectionality, I'll just briefly define as a framework for understanding how groups and individuals' social and political identities result in unique combinations of discrimination and privilege. Examples of these factors include gender, sex, race, ethnicity, class, sexuality, religion, disability, height, age, weight, and there are others. The installation is an abstract representation of the complexities of intersectionality. So this is the final piece installed. As one walked around the piece, the hovering black elements intersected differently with the many lines. Each line is a vector representing a single part of a person's background, heritage, culture, etc. This is an in-progress image of the install. It was a little bit insane to put together. And this video on the left shows former USC student and possibly future escape artist Lindsay Smith navigating to the back of the piece where we needed to change something that wasn't right. And then the image on the right shows the simple wall connection detail for this piece. My initial intention was to tie each knot such that it disappeared by making them as small as possible and then trimming the tails perfectly. But as the work grew in place, I found that the larger visual knots and even the paracord tails added to the piece. So, because I think they tell the story of how this is made. 440 knots tied by hand. Again, a representation or a reminder that even through an overall system, even though the overall system was created from a script that I wrote, there was significant hand and craft needed to actually make the installation. So that was a little bit of introduction. I just want to sort of explain kind of how we got to where we are. So Entangled Agency is the first of the two projects I'll show in more detail. And it's my first permanent public art commission, commissioned by the Evans School of Public Policy at the University of Washington through the Washington Percent for Art program. It's a two-story suspended sculpture near the main entrance to the building. Being the School of Public Policy, faculty and students and staff were all very interested in the process and the outcome. I met with the different groups several times during the design process. Discussions centered around student agency, equity, and diversity. The commission was part of the complete renovation of Carrington Hall, the second oldest on campus. I wanted to really integrate the project into the historic hall. So it was really important to me how the art meets the building structure. So you can see in the elevation how the piece is suspended from the floor plate between the second and third floors, and then it passes through a large opening in the next floor plate, takes an oblique turn, and terminates at the cafe near the entrance to the building. So the building is on the left when you're looking at the plan. So this video shows in detail, I'm wondering, is it ready? This video shows in detail how the system is created. We start with a line-based system placed in three-dimensional space where we want the artwork based. The script creates a network, and then the lines are gathered into bundles. At the bundles or intersections, nodes are created to highlight and suggest influence of the line-based network. The node locations are established at datums throughout the piece, and the shape of the nodes themselves are directly formed from the vectors that pass through the nodes. The concept of the piece was to map the unseen forces at play when public policy is shaped. One interpretation is that the nodes represent humans intertwined with the larger dynamic forces of public policy. The nodes gather and shape the line-based vectors, suggesting the importance of human agency in public policy. And then this is just another image just showing the drawings. These drawings are really important in our office. We make these drawings on a regular basis as we're producing the art to help us both communicate the ideas to others, but also to ourselves. So these are renders. We also make these as part of the design process. Here I want to note that it's not really possible to separate or even present these types of projects as design and then fabrication. We're constantly working back and forth between form, shape, composition, connections, structural abilities, and the way it will get fabricated and installed. It's a very iterative process, partially because public art projects are on a very fixed budget, so the budget's assigned right at the beginning of the project. So you have the money you have, and however you have to make it work. But also because I always want to be in very experimental territory, which requires this back and forth between fabrication, materiality, structural concerns, etc. So in the final design, all the paths of the rods are unique, each bending differently in 3D space. That's the way the script was written. I wanted all of those to be three-dimensional. As a mapping, I felt like this was the most accurate. At this point, we were ready to start figuring out how to fabricate the nodes and rods. There turned out to be problems and incorrect assumptions for both, of course. So for the rods, the hope and plan was that these could be fabricated using a CNC tube bender. But I learned, again, during the process, and maybe a little bit later than I would have liked, that the CNC tube benders have to be calibrated for each bend to take into account what happens when metal is bent. There's a kind of kickback. So we had 272 different 3D rods to bend in space, and this was the plan for bending them was not going to work. So I'll talk in a minute about how we worked around that. And then we also had problems with the nodes. So all the physical connections and the lateral bracing to the building, we worked out with our Seattle-based structural engineer, this hilarious guy named Gary Gill. The most challenging engineering problem was around the nodes, and we quickly discovered some of these problems. I wanted them to be structural, but we weren't really getting there on this timeline. You can see in this image not even all of the node prototype tests that we were making. We were constantly trying different materials, different forms, different ways for the nodes to connect into the rods. At one point, we were experimenting with this very flexible TPU filament. It literally sort of bends in half. And I remember being on Zoom with our engineer trying to convince him that this super flexible node would just kind of hold the thing together and it's going to just waggle around in space. Seattle is in earthquake territory, but this is a sculpture. It's not. No one is. There's no forces bearing down on it. Nobody's standing on it. But he wasn't buying it. He was like, "This is not going to work. It needs to be much more rigid." And so we were kind of running out of time, and this is even before we had started doing all the structural calculations. So this image shows some of the final shop drawings of how we made the final nodes work. We had run out of time making them structural, and so instead we decided to use the nodes to hide the physical connections. And then this image shows a little more detail, those kinds of connections. There's There's one-to-one line connections that were needed to handle the way that we assembled the scaffolding. We assembled it as we built from the top down, because of course it's suspended. We dropped the scaffolding down the whole 2 stories as we assembled the piece. And then going back to the problem with the rods, with the CNC fabrication methodology, a bust, we turned to hiring a single Washington-based fabricator named Glenn, who ended up fabricating all the rods without any CNC assistance. This is the 2-dimensional pipe bender that was used with the rods, and then Glenn hand rotated these in 3D space for each bend. So while I was picturing this pristine fabricated workflow of rods being cleanly pipelined through this sort of 3D space CNC process, in the end, this very not tidy shop, which is Glenn's shop in Seattle, is where all the rods were fabricated with the 2D pipe bender and the kind of hand calibration of the 3D space. I flew up to Seattle at the height of COVID, and we did, in this covered space, we assembled a prototype piece, which was approximately 1/12 of the entire sculpture. We always prototype at full scale, and we always learn a great deal. It's always beneficial. Ultimately, it saves us time, money. Time is money. And we also discover usually some borderline fatal flaws in the assumptions we're making, or the sort of ideas that we're thinking are going to come together. And then that gives us time to adjust before it's really difficult to compensate. This is just a pile of the rods, partially bent, partially unbent. And then here's some of the final notes. I think one interesting aspect of the conversations with the different committees involved when you do public art, because there's always committees involved, is how important the color was. The nodes could not be all white or tan, or really any color that was associated with skin color. This is an idea of representing people, and we needed something neutral, and it needed to be a non-skin color. So we ended up with this blue-gray color. I think it's a little bit funny because it's actually a color that was used for German World War II armor, and I know that the committee would not have been okay with that, so we didn't tell them that. The final 3D printed nodes were all outsourced. We did not print them in our studio. In the second project I'll show you, we switched that around. And then here are some final installation photos. It was tough. It was a tough installation. It was done before the COVID vaccines were out. There was a lot of oversight from the university in terms of health procedures. We had to wear masks the whole time. We started at the top, so this is up to the top of the second story. We have the scaffolding, and like I said, we're dropping the scaffolding down in stages as we build downwards. So this shows 2 levels, about 8 levels total that was completed. And then this is actually, it comes all the way down, it bends, and it dives into the first floor ceiling panels. All the elements were in place, and it was really difficult to secure it. There's a hidden unistrut system, you can sort of see it in the photo, up underneath the drop ceiling. And it took a lot of brute force to get it to meet exactly where it was supposed to meet. This image shows how it does appear to grow or emerge from the second floor ceiling the way that I wanted it to. So it's disappearing up into the baffles and the lighting. Up there above that, you can't see, there's an entire plywood collar for lateral bracing. Again, this is the idea that it shouldn't just waggle around. It needed to be quite rigid for earthquake, for lateral bracing. And it's also actually navigating HVAC ducts, sprinklers, electrical conduit, a bunch of other things up there. And this shows the oblique turn at the first floor where it dives back into the drop ceiling after the ceiling tiles were in place. And then here's just a few more final images. It was kind of anticlimactic because the university was closed. There were no students around. Nobody had seen it. We worked hard to put it in. When we went to photograph it, the local installers that we worked with graciously showed up to be pretend students in the photos so we could have somebody in the shots. So these are our installers. This is, again, the school that's probably full of hundreds of people now, but at the time nobody was in there. So it's me and Jesse, who was here instrumental in this. A few more images of this. cafe. Again, no one had ever eaten there, no coffee had ever been made. Okay, so then this is the second project I'm going to show. This is our most recent permanent public art installation. It was just completed last year in Scappoose, Oregon. And I very much wanted to use this commission to push further on the node that didn't really do much in the last project. And I gave the whole installation the title, the working title, The Power of the Part. So the building and the client are part of Oregon Tech, and they were a perfect match for my goal. Because it was commissioned for a brand new building housing the Oregon Manufacturing Innovation Center, which is a cutting-edge additive manufacturing facility set up to create a technology and information bridge between Oregon Tech and then commercially fabricated, the industry of commercial fabrication in the state of Oregon. So while the nodes in the Tangled agency were just hiding the structural connections, in this project I wanted them to do everything. I wanted to be the only mass customized elements, and I wanted the line-based system to be straight tubes, no blend, fabricated in fixed lengths, no bends. And so for the lines, we're using simple old school mass production, and then the parts, the nodes were the mass customized portion. So from the beginning, I also wanted OMEC, the client, to participate in the fabrication. I presented that to them in the very initial proposal. They have all these fun machines, and they're all based on additive technology, and this is what we were doing. So I convinced them that they should be a part of the project, and they were excited about that. So, and I'll show a little bit more about what they did. So we put all, like I said, we put all the smarts in the mass customized parts, including instructions for how to put it together. So each node, you can see it in the photo, each node has the instructions directly encoded, 3D printed on the node. So every hole has the information that tells you what size rod goes into that part and what node comes after it. So you can literally put the whole thing together without any drawings, just following the encoding from the nodes themselves. So very different than the last project there. A lot easier to put together. Again, the design is a network, but this time it spans between walls with no overhead support. So again, trying to showcase the structural capability of the node and the system, while also sculpting a spatial condition, and it spans over 30 feet. So modifying the scripts that we used for Entangled Agency, we created an initial network spanning between 3 walls of the lobby. We used other scripts that we used before. We modified those as well to sculpt each node relative to its position in the network. The number of lines that intersect each node directly impact the size and shape of the node with no two alike. And then this is a bird's eye axon of the design. Again, for each project we produce these drawings showing how the art integrates with the architecture. And then this is a section axon. So in this piece there's over 880 different parts in the final piece. And again, as I said, we always prototype a full-scale portion in our studio. So this prototype here, that prototype there. In this case, we learned some good things, not just bad things. We learned that it was overall lighter than we thought it would be. But we also had some nodes failing, cracking, splitting. So we were starting to look into some of that. This is just our prototype mounted on the wall. And then, so after the prototype phase, we started the real engineering, because all these projects have to be engineered. They have to be stamped. They have to be approved by structural engineers. So this project we worked with LA structural engineer, Nous Engineering, and with Matt Melnick, who I know a lot of you know. And we would give his firm the 3D Rhino files, and they would analyze the network both for spanning and for spanning capability and for deflection. So you can see on the image on the left, it starts to show in blue the deflection that would happen. So now also analyze the subset of the nodes to evaluate their performance, because of course they are the structural glue of this thing. There's no hidden hardware inside the node. The plastic is the structural system. So the areas of highest stress are shown in red, and not surprisingly, where the rods intersect or into the nodes, that's where the forces are highest, impacting the node itself. And then this image, I really don't know what this image is. They sent it to me, and I thought it was really cool. I'm not sure what, I just stuck it in. So I'll find out later. And then we also 3D printed the cubes that are the actual infill, the exact infill that we're using in the nodes, because of course the nodes aren't solid plastic. That would be too expensive, too heavy, too time consuming. So now to perform these crush tests, and we crushed the cubes in all 3 axes as a test to see if the nodes are going to succeed or not. So before, when I said the nodes were failing, we had already increased the thickness of the surface of the nodes, the solid surface, and then we had tested various different 3D fill patterns until we kind of got to the combination we thought was the strongest. And then those are the ones that we did the fill test and gave them to Mouse, and they said that they crushed them till they pressed them until they failed, but they know how much force they're putting on them versus how much force we were putting on them, so they passed. This is a shop drawing showing the connection of what I might like to call the smart node to the mass-produced tubes. So again, the tubes became very, very simple for this project. They were fixed lengths. Anybody could cut them. Straight cut, 2 notches, always the same color. Very simple. And then we pre-assembled everything in our studio. This is different than what we did in Seattle as well, before we shipped it, which meant there were way less problems in Oregon. And this is another thing I learned from the last project. By putting everything together in chunks in LA, we knew if we were missing a part, you can imagine you have 880 parts, the possibility of missing something, forgetting something, making the wrong thing twice, whatever, is high. So we caught all those kinds of problems before we ever shipped it to Oregon. And then I also learned from the last project that taking on the fabrication in our studio was beneficial in terms of both budget, because we paid for the printers up front and then we ran them almost 24/7, because a lot of the nodes would take 12 or more hours to print. And then that gave us more control over the deadlines that we needed to meet. So we ramped up to 5 in-house printers, and then towards the end we borrowed a 6th one when we were kind of on the edge of making the deadline. And then we also, just for fun, we moved offices in the middle of that. We had to pack everything up, move from one part of downtown to the other. We left the printers running the whole time while we were packing, and they were the last thing to be packed, and then they were the first thing to be unpacked, and we started running them then while we unpacked everything else. So, and then, as I mentioned before, I wanted OMIC to print part of their own art piece as a showcase. Am I running out of batteries? Is that what you're saying? Oh. Does it say that? Yes. That's telling me. Thanks, guys. So much for technology, huh? Okay, so is this... Now let's some of this here. Hold on.
Red dot, red dot.
I'm going. That's hard. I'm going backwards.
Standing. There you go.
Okay. Woo! Okay, so this is the beginning. Is this video running? So this is the stainless steel node getting printed. So it's cool. I'm going to go back. So this is using their machine to stainless steel print a node. There's one of those prototypes over there. So the way this machine works out, it lays out the powder, which, as you can imagine, stainless steel powder is pretty expensive, and then it uses a laser and argon gas to fuse the powder together. And then once it's printed the whole thing, all the leftover powder can be reused, so you can actually, salvage. But it's like laying out a layer, fusing, layer, fusing. And then this is the entire art piece packaged into my Subaru and fit in one carload. I did not drive it to Oregon, I just drove it to FedEx. But going all the way back to the metal sculptures that I showed you at the beginning, I find it intriguing to push on a design or system such that the entire thing can pack away really small before it's assembled. And then when it's assembled, it encapsulates or otherwise sculpts a much larger space or volume. So I think it results in an interesting and efficient ratio of material and parts relative to the volume of the piece. I guess the test is always can it fit in my car. So these are some images of the installation. The installation went much faster, I think for 2 main reasons. One, we had put together the whole thing almost completely in 8 chunks. We didn't put the 8 chunks together, but we knew we were not missing any pieces. Actually, I think we were missing still one piece, weren't we? And I had to FedEx one piece. Anyways, and then I think more importantly, because of the parts themselves, with the text IDs literally on there, that made the assembly much easier. So the power of the part idea worked out pretty well. So on here you can see 3 templates. We plot these full-scale templates on the walls. We start placing the pieces in space. We assemble the chunks down on the ground because obviously it's easier to be working on the ground. Then we lift them up in space to place them on the wall, the chunks. I like this image because it starts to show how it's growing from the 3 different walls, similar to the way a bridge is built, and you're just hoping when you get to the middle, it's all going to go together. And then this video is an informal test of the rigidity or structural integrity of the final piece. So that deflection we were expecting, and it's actually quite important to have some deflection because obviously as we're putting the thing together, we need the deflection for the tolerance just to get everything to go together. And then this is a view from underneath. This is one of my favorite views because I think it closely replicates the plan drawing showing the overall composition and how it interacts with the building. And then here's some more final images of the piece. This was after COVID. I don't do anything with it. This is looking back towards the entrance. Looking up through the piece. And I didn't mention, so there are 7 different colors for the nodes. We were printing, that was one thing, just keeping track of the nodes, like which node is which color. And then the rods were a different color as well. And then this image is interesting because you can see the stainless steel parts mounted on the wall and then the PLA parts right next to it, away from the wall. There's a couple more images. And then I'm happy to say that we now have another commission in Washington State, our biggest commission yet. It's double the size, double the budget of the last one, and it's for the Forensic Western State Hospital in Lakewood, Washington. And I'm thinking already about what unseen systems or ideas could be mapped that might be relevant to a forensic hospital community, and that's basically a hospital mainly for incarcerated individuals. So it will be an exterior piece, so it's going to introduce a whole bunch of new challenges. And as a forensic hospital, there's also a security element where no portion or piece of the installation can be extracted from the art and used as a weapon. So like that's a whole new thing that I have to think about. I'm interested in using maybe more pieces, smaller components, rods and nodes. On a pragmatic matter, I'm thinking about going much denser. Part of the issue when you have an exterior piece is that it shouldn't be climbable in any setting, right? And that obviously everything I make is super climbable. So I haven't figured out how to do that yet, but we're looking at that now. And I'm also interested in more complex manifestations, maybe encapsulating space more rather than just shaping space. So. The last thing I just want to say, and this is mainly to the students, I think, I started doing this kind of installation work right out of SciArc. I'm not from a privileged background. I do not have economic connections, network connections. Emily and I made our first installation out of paper, string, and paper clips, and we got it published in Interior Magazine. It was like a $200 budget. So I think what I want to say to the students is like, just start making. I think, it's hard. It takes a while to get there, but I feel like, I'm on a trajectory and I'm happy with where I'm going. So thank you all so much for coming. I think I've talk fast, so I probably can answer a few questions if anybody. Yeah. No, we just got the commission. I'll let you know. Yeah.
So, thank you for the talk. Because of this talk, I've now had a need of your work. Okay. Because the more obvious reason of your work, one more obvious reason of your work is, let's talk about density of dots, and let's talk about the point clouds. And if the points of the point cloud, density of the point cloud, and the size of the points themselves are shaped in a way that they behave a little bit like coupling of pipes, right? And the custom coupling, have facets, so that depending on which angle you're looking at, the density of dots, we can have like different X, Y, X, surface conditions. That's maybe one more obvious way of doing your work. But the less obvious way of doing your work that just struck me as you're talking was let's maybe connect your work to the range of columns. But more specifically, whereas anti-mediatex, let's say column system, is similar to the exposed skeletal structure. It is not without drums. It has drums, right? But when you look closely enough, the anti-mediatex also has in themselves, let's say, segments after segments after segments. It's just that macro system is entirely connected by with no coupling. Yours, though, if we were to, let's say, disregard the verticality and compression of the column and allow the column to go in multiple directions, which yours does, right? And so as an extension of something like the project, your drums, like the couplings are more like drums. Because conventionally, when you think about, let's say, a column, just a shaft, right? The drums in themselves also have these kinds of pipe connectors between them. Just that you reverse the proportion between the pipes and the drums. And the drums themselves are super small and the pipes are incredibly long, right? And with that in mind, I was thinking that's a super interesting, again, new read of your work. And I wonder what size of drums, like what are the ways in which the shapes and size of the drums really increase the difference?
Yeah. I mean, the stainless steel nodes are, I think, kind of give me some hope if the budgets get bigger, that kind of stuff can start to happen, right? Because the PLA plastic can only take you so far, probably in the scaling up of these kinds of things in terms of forces and the physical scale that they can handle. But yeah, it's an interesting observation. Yeah.
Lisa.
Oh, wait, Ginger. Go ahead, Ginger.
I thought there were not other questions to ask, but it occurred to me like a year or two ago that if I had the time, it would be fun to do a tentative volume on architectural projects that are designed to be produced by CAD and will wind up being produced by human labor-led, more conventional senses, either potentially the same or the really laborious techniques, which I've seen in cases where, like 20 years ago, the American design project was built in China and it's entirely way cheaper to build it, like with shop tools. So this was the case, right? But this was I misheard you with the Washington cost, is that right?
That it was more labor to produce because
or that it wasn't CAD produced the part of it in the end that you thought?
We couldn't CNC bend the rods.
Yeah. Oh, okay, yeah.
I was picturing lovely little assembly line and just feed them in and they would all bend in 3D space. So it was very labor intensive, yes.
So I'm just wondering, like, to me it's interesting because then it's like the question of, we think that we're designing things in such a way that they can be produced by certain tools and processes, but in some ways it's really just an enabler for the imagination to be producing things that are actually going to be produced the way that we've always been producing them. And so I'm just wondering, one of your lessons was to make these things so they were more CAD produced, perhaps, right? But I just wonder if you've thought about that much, because we go with this question of technology so, like, is the machine, is there something about the process of things being machine produced that is important, or is it something else? Like,
I think, I mean, I personally, I just get excited about technology because of my background, but I think if I may be addressing your question, I think that, I said this earlier, like technology is inevitable. It's coming. We can all sit around and debate if it's good or bad. It doesn't really matter, right? It's already here. And I'm one of the people who believes in this sort of exponential, the way it's going to exponentially explode. Some debate, that's a whole other debate as well, but I'm in that camp. So given that's the case, I think, and this could be a whole 1 hour conversation, I'll try to keep it short, but I think that, again, I'm interested in not fighting it, right, but figuring out what we're losing from doing these things differently and trying to bring that back, right? Like, so, again, it's futile to resist, in my opinion. So instead, let's be aware, let's be critical of what we're losing, of what's happening, what's changing, and as architects, as designers, design accordingly. I don't know if that's really
yeah, I think even like things like art crafting machine, where the machine becomes a kind of inspiration for new types of forms that wouldn't have otherwise been thought of. In some ways, that's often what's happening, where we say it's being produced in a certain way, but in fact, you're imagining something for a machine that doesn't actually exist yet.
Yeah. Oh, sorry. Let me got that.
So Lisa, I have a question on, sort of, I don't know, I love everything I always see from you folks and everything, but the thing is, you're insanely obsessive about some of these things, I would argue, and I also think to myself, because each time you become sort of the expert in, folded metal or riveted things together, or freaking vinyl welded, clear fabric.
Radio frequency welding.
Yeah, radio frequency welding. I mean, all of these things are so really interesting. I don't, and I love the fact that you keep progressing is the thing, versus other people I think might sit on their laurels and just keep going radio frequency welding, I'm going to do this one, I'm going to do that one, etc. What is that? Why, or why don't you circle back? Why don't you circle back on some of this?
Well, I do. I mean, I hope to use the system that I just showed you, the Lilac Fizz system for the forensic hospital. I don't know exactly how. So sometimes I jump, sometimes I don't jump. I mean, I am learning that it's really expensive to jump. It takes a lot of time and effort and design hours to jump from one whole media, technology, fabrication methodology to another. Like it's like a lot of my time, it's a lot of time of the people in my office. So I'm trying to be smarter about it, but I get excited and I jump because it's exciting. I don't know.
That was great. Thank you so much. I was thinking the discussions of the technical discussion, some of the things that Ginger and Scotty brought up about how things are made versus how they're represented. It comes down to that, and I'm struck by it. I think it's really fascinating reflecting on how you present, which I know you presented the work beautifully, by the way. But I think the way you talked about what the intent was, what the representational intent was, what the idea was, versus how it was made. So whether you had to do the structural connection inside of the actual joint, or in the joint became a representation of that. Reminds me of Mises' Barcelona Pavilion and the chrome column covers or something like that, versus the stainless steel welded together. And I wonder, what is your take on that in terms of when you have the idea that you want to show what you think it's capable of, and capable of representing either aesthetically, conceptually, technologically, versus saying, I'm going to be true to the system, or this is going to be the true representation of what this material is, and what it's capable of, and that sort of thing. It's a constant struggle in architecture, I think.
Yeah,
we all look at it. I just would be curious to know your thoughts on that.
I think I lean more towards, well, when we show the representation at the beginning to a client, we don't even know what the connections are, so we're not representing them because we don't even understand what they are yet. But then once we start to resolve what they are they bolts? Are they radio frequency welds? Are they rivets, whatever? I usually try to convince whomever it is I need to convince that those connections should be expressed and not hidden for the most part. The nodes was maybe an exception where the nodes were inherently there. I wanted them to be structural, and it wasn't working out. I mean, they did perform in sort of keeping things together. They were performed in terms of making the thing buildable without those nodes. I think we would have just gotten completely lost in the 272-bit rods and never having finished the thing. So they were still performing, but I tend to want the tectonics to be expressed, I guess. That's just me personally. I know there's some there.
Thank you so much for the presentation. I really appreciate it. I'm so sad you didn't get to see your first installation of OS. That's gorgeous. But I really appreciate the technology and bringing a metaphor to policy in terms of. I'm really curious. I know it's really a new project with the Forensics Hospital. Like we're dealing with mostly I wonder what types of outcomes you
Yeah, I'll be really honest. I have no idea yet. Like we just got the commission, and I haven't been up there yet to see the site, and I'm super excited and also a little bit overwhelmed about some of the challenges. So I don't know. I feel like there's a lot of potential. I guess I'm excited about learning more about that community. The hospital the amount of money that's being put into this hospital is crazy. There's 4 other artists, there's 5 courtyards, there are 5 different artists, and I think Rob Lay actually has one of the commissions as well. So, so it's an exciting project, but yeah, I don't have an answer for you yet. I hope to report back. Scott.
It's great to see this work. I remember seeing your first installation before I met you, and your helper was and stuff. But it's great to see this because you are, as you said, you're kind of building a scale each time. And it is, like, you can raise my anxiety, like, seeing all the logistics and connections. You can really feel that. Just the thing that's amazing about these projects is that you are touching every component. You're not passing this off to something else. You're doing everything else as much as you can, which is really amazing. It's really great to see this. But the scale of this project, the scope of this project, even if there's this new project where you can't do that, and you can't climb, just look at track. But it's just really great to see this work.
Thanks.
So, I'm really almost touched on the description you have of this interface between technology and human, right? And it's very, again, in a very communal way, right? That it's how do we screw up when trying to build the robot? Recognize the material world, not moving the robot. But I think it's evolved into something much more, and I really like talking about it, but it seems to me that from the point where you do the installation in Washington, right, and a lot of things were hoping they couldn't achieve it, but they couldn't achieve it, or maybe you misread it, maybe it was underperforming, right, or the software. And that while you guys had a massive learning curve, it seems to me that the software hardware is also developing, right? And it's also more sophisticated and more capable.
For sure, yeah.
And so there's this intersection of you guys almost keeping up with each other, you and the robots, right?
Yeah.
The software and the hardware.
Yeah, exactly, yeah.
Yeah. And so that is where things getting really interesting, right? Not so much of the problematics of it, but rather, can you keep out ahead of it and keep telling me what to do?
Yeah, that'll be the question for all of us.
I'm really fascinated by your kind of exploration of the nodes specifically and looking at the materiality between your 2 different projects. But specifically with your like Lilac Fizz project, what was the kind of motivation behind the coloring of the plastic in the sculpture?
Well, color is such an interesting topic in public art in particular. Public art is interesting in and of itself because I was thinking about this when I was preparing this lecture. Like public art is a lot more like architecture in a sense because you have a client and the things you're putting out in the world are forced upon the public, right? Like you hang a painting on your wall, you can look at it or not look at it, but public art and architecture are both in the public realm, and we are all, interfacing it with it whether we want to or not. So, and then you add in color, which is such a loaded and personal thing. I think it does get difficult to pick, choose, use color in public art. I think you can see you can see on the slide. Even though I dress in mostly black, I really like color in art, and I don't know. I'm not sure how to answer the question. Each piece is different. It depends on so many factors. Like I talked about with the one in Seattle, the color of the nodes was a very sensitive topic, right? Because it represented humans, right? In this one, in Lilac Fizz, it's not representing anything except structural forces, and maybe they should come in pink and yellow and green. I don't know. So I don't know exactly how to answer the question, but I think it's every time we spend a lot of time on color. Maybe is one way to talk about it. Like these are not afterthoughts. We have a bazillion colors of PLA in our office that were not the right color, that we ordered this color and that color and that color, and powder coat as well, powder coat test to get to the colors that we feel like work best in the lighting, the existing palette of the architecture that we're integrating with, any conceptual things that go with that. So there's a lot going on there, I guess.
So work is fascinating, so beautiful, and I love the technology and how you're working with it, and just going from one project to the next, and because the nature of the work is really important for you to really love your work, and I think it's important for all of us to really love our work and enjoy what we're doing. And with that being said, one of the things that I've noticed is that your fascination with the node begins to be more and more, and the actual heights are shortened in that last one too. And because they are white, they're meshing into the background, right? So the nodes are what you are presenting. And so when I started going to the next project as well, I remember in much of what we did, I could almost see the nodes becoming the most important part of it, and also maybe they are the structural part, but perhaps the lines begin to disappear and they become a weaker element physically as well, so it's not triangle or cybernetic, there's a magnetic way that the nodes could actually hold the space as well, and I just think that that's an interesting progression into just that.
Yeah.
We're getting the lines, what would that be?
Yeah. The lines are actually lavender, but we did a version where they were white, and they were literally disappearing, and I loved it. I mean, Jessica, we were talking about it. It started to look like a flock of birds, and we presented again, going back to this committee in color, and we talked to them about white and the lavender, and we also had a mint green color. And in the end, the committee had a vision. I had sold them on a vision of something, and then it's hard to then, move past that with a whole committee of people, some who were architects, some who were artists, some who were maintenance facility people, etc. So in the end, we stayed with the lavender. But I like what you're saying, because we're already thinking about that for sure. Yeah. Yeah. Well, I'm teaching a graduate thesis section right now, and some of my thesis students are here, and we're taking on, to a certain extent, that exact question. I still believe that we have an incredible amount of agency. I think what we need to do, I'll give you a short version of this. This is, again, a long topic. I think we have an incredible amount of agency, and we will remain so as long as we are staying aware of technology. I think personally embracing it the way, like I'm saying, embracing it, but being critical of it, being asking ourselves what can it do for us rather than what will it do to us. I think we have many decades to go before the scarier questions might come. So I think it's 1 o'clock, so I know studios are starting. Thank you all so much for coming over.